Hey everyone, Mike here. I'm back this week to talk about NSX-T routing. Don't be worried, it's not too scary, and I promise that we'll get through it. I will say that this is going to be the first in a small series specifically talking about routing. I wanted to break it up that way because there is some new concepts and there's some new terminology, and it can get a little confusing, so I want to make sure we kind of take time and take it in bite-sized chunks. That said, I hope everyone's doing well. I hope you enjoy the COVID-19 haircut. To be fair, things are opening here, but I haven't been brave enough to go out a whole lot. Don't get me wrong, there's things I'll go out for. Panera, bread bowls, chocolate of any kind, Checkers french fries, anything at Chick-fil-A. I've found personally that the biggest reason people get confused about routing in NSX-T is that they overcomplicate it. At the end of the day, it's just routing. We're talking about virtual routers and virtual switches, and that's really it. So there's not a whole lot to it. But guess what I'm gonna do today? So I got 2 slides for you, and then we're gonna get into NSX-T, and we'll actually look at how the routing is done, and I'll show you not only what it looks like on a slide, but what it actually looks like in the CLI and the GUI. So as you see here, I have a diagram which kind of depicts how my home lab is set up. You'll see at the top we have this redundant pair of CSR 1000 Vs. These are just virtual routers that are running as VMs in my home lab, and I've placed them there so that they kind of simulate what a real network would have, which is some devices that are running BGP to the NSX network. So in this case, on the NSX side, I'm actually running BGP from what in NSX we call a tier 0 router, and that's this guy right here. So you can kind of think of a tier 0 as the on and off ramp into and out of the NSX environment. So everything goes through the tier 0 regardless of where it comes from, more or less. There are some very specific rules when we talk about regular VLAN networks where that isn't true. But generally speaking, it's safe to assume at this point that everything goes in and out of the tier 0. So with that understanding, the tier 0 is ultimately just a virtual router. It's not anything special. It runs BGP between the physical network and NSX. We can do route filtering and kind of all the BGP manipulation we would want to. We can also do things like connect networks directly to that tier 0 router. So you'll see here in this drawing I have the web segment directly connected to the tier 1 here. If I wanted to, I could actually disconnect that and connect it directly to the tier 0 router. So that begs the question, do we really need a tier 1? And the answer is maybe. You don't have to have a tier 1 in NSX. All a tier 1 is really used for is kind of further, more granular network control. What I mean by that is, let's take an example. I have this production environment you see on the screen here, and I've got a web segment and an app segment. And if you look at the IPs on those segments, I have 10.200 and 10.201 here. What if I wanted to have a dev environment though, where I wanted to duplicate that entire environment and kind of have this second environment right here, and I have overlapping IP addresses? I couldn't do that if I created another segment and connected it to the same T1, because I can't have overlapping IPs connected to the same router. But what I can do within NSX is this. In this example, I've created a new tier 1. In this case, I've named it T1-Gateway-2, and I've connected it to the tier 0, just like the other tier 1. Only in this case, now I have new segments with the same IP address connected to this T1. So by using NAT on the T1s here, we can actually have overlapping subnets, and it works just fine. And in many customers, that's what they opt to do. And that's just one example of why we would have a T1. There's other very valid use cases where you would need multiple T1s. That might be something like, maybe I want a dedicated router for an application. Maybe I want to have a multi-tenant deployment where I'm going to give access to these T1s to my tenants, and I'll control the T0, in other words, the in and out of the environment. So there's a few reasons why it would make sense to have a T1. So there's another important piece to this puzzle. So I talked about T0 and T1 and how ultimately those are just virtual routers. But the other piece to that is that for every router, whether it's a T1 or T0, that we have multiple components within that router or multiple pieces of that router. So we have a T1, and every T1 has a distributed router component, and in most cases also has a service router component. Now the service router component is basically used for centralized services. Think DHCP or NAT. Those are kind of the big ones that I see. So the SR is always living, in the case of NSX-T, on the edge nodes. The edge nodes in NSX-T, I'm going to have a deep dive just dedicated to those because it can be a little confusing at first, but for now, let's just understand this. The edge is the on-off ramp, and it is a VM that is dedicated for that on and off ramp functionality. Now you're probably saying, but Mike, you said the T0 was the on-off ramp, and you'd be right. The T0 lives on the edge node. So to summarize, if it's a service router, whether it belongs to a T1 or T0, it lives on the edge node, as you can see here on this slide. If it's a distributed router, it lives on the actual vSphere hosts themselves. And this actually lives in kernel. There's no appliance or no VM dedicated to this functionality like there is on the edge node. In the case of the distributed router, it's fully distributed on every transport node, which means basically in this case, we'll say vSphere hosts. This is what gives the ability of NSX to provide a default gateway for all of these different networks on every host. So now when I have a VM, say VM A, and it moves from host 1 to host 2, the VM's default gateway will already be at host 2 when it lands there. So it will already have a network to route to. And what's really cool is, let's say we have, in this case, I go back here to our example. Let's say we have this web segment here and we have this app segment. And let's just say, for the sake of argument, that both of these are sitting on the same physical host. So I have Web01, Web02, and App01 all sitting on the same host. They can route within the host without ever leaving that host and going to the physical network. And the way they do that is because they have a distributed router component on that host, which allows that routing to happen. And I'm going to show you guys this, so don't get too confused here. So that's enough talking. I want to get into the GUI and some CLI maybe, and just kind of show you guys what this looks like, because I find that a lot easier than just kind of talking on and on. So let's take a look at it. I'm going to hop over to vCenter first. I want to kind of show you the setup I have, and then we're going to get right into NSX-T Manager and some CLI as well. So let's do that. All right, so here we are. So we're in my vCenter. I want to give you guys a lay of the land just to kind of make things clear, kind of take the information you've seen on the slides and make it real. So I have a compute cluster, which basically is where I'm going to put my VMs that are actually my workload. In this case, the application itself. So I have my App01, Web01, and Web02 VMs here, and I have 2 hosts inside of that cluster. You'll see also I have this edge cluster, which is just the name I gave it, and I'm using this for my edge VMs. And keep in mind, just a refresher, that the tier 0 sits on the edge VMs, and this is where our service router components sit, or the SR. So this is all the centralized services, DHCP, NAT, that kind of thing. So that's going to be done on these edge VMs. And those are actually deployed from NSX-T Manager. So I will be doing a video on how to deploy those, and I will actually be doing a deep dive as well, specifically on the edge architecture. So be sure to keep an eye out for that if you want to get into that. But for now, we're just doing an overview of routing as a whole, so we'll pass up on that for now. We have these VMs here, and I want to show you guys kind of the first thing that's really cool. So if we look here where the VMs are sitting, I want you guys to focus in right here on the host. So this is on App01 is on 254.11, Web01 is on 254.11, and Web02 is also on 254.11. Now, if we take a look at the network settings for these VMs, and I just picked one at random, I got Web01, you'll see here that the network adapter has it selected as web-seg, which is our NSX created network. If I go here to browse, you'll kind of see the first tip here. So you see these little switches that have an N next to them? That means that they were created from NSX-T Manager. So that is the difference between them and a standard distributed port group, as you can see here. So management v251 DPG, or distributed port group, doesn't have that. And then we've got the N next to app-seg and web-seg, which are the networks, if you recall from the slide I showed a little bit earlier. So we're going to close out of that. I just wanted to show you guys how the networks were added and that they are showing up in vCenter once we've created them in NSX-T. So we're going to cancel out of that so we understand that the VMs are on the proper segments. So let's take a look real quick at NSX-T Manager. I'm going to show you the actual configuration for the Tier 0 and Tier 1. And then finally, we're going to wrap it up by actually showing you from a CLI how the configuration is actually being realized inside of the host itself. So let's do that. I'm going to switch over to NSX-T Manager. I'm going to throw my login in here. And I'm going to do it incorrectly. Let's try that again. Voila. Second time's a charm. All right, so We're inside of NSX-T Manager. I will say if you haven't seen my other video on how to deploy the manager, you should definitely check it out up there. I'll make sure that you get a link in this video. That video will walk you through how to deploy the manager so that you can follow along with these steps. So let's take a look at networking. So we're going to go to the networking tab because we want to look at our tier 0 and tier 1 routers. Now, what you'll see here, you get kind of presented with the network overview, which shows how many routers you have, DNS, DHCP configuration, how many NAT rules, kind of all of that, which is useful if you're kind of in a larger deployment, but from a lab standpoint, I prefer to stick to the left column right here. So we're going to start at the tier 0 gateway. So we're going to hit select tier 0 gateway. Now inside of that, we'll see I already have a tier 0 gateway. You'll see it's in active standby. So what that means is I have my Edge 01 VM and Edge 02 VM. And inside of one of those, I'm not really sure right now off the top of my head, but inside of one of those is Mike's tier 0 active, and the other one has Mike's tier 0 standby. So let's take a look real quick. We also see linked tier 1 gateways. If I click on that, you'll see here it shows me T1-gateway, which happens to be my T1 that I configured before this video. You'll also see it shows an IP address here for the plumbing between those two routers. That's actually completely auto-generated, and you can configure that if you need to. So you're not stuck with this range, but it's not something that I manually went in there and put in. So I'm going to close out of that. The other thing that's relevant here is linked segments. You'll see 0. So that means I don't have any segments directly connected to the tier 0. In this case, as you remember from our diagram, I connected all of the segments to our tier 1. So let's go take a look at the tier 1 real quick. So I select tier 1 gateways, and then you'll see I have T1-gateway, which is the tier 1 that showed up in the last screen. You'll see here it's a little bit different. It shows the linked tier 0 gateway is Mike's tier 0, which we were just on. But this time I have 2 linked segments. So let's click on that. So you'll see here we're populated with app-seg and web-seg with their respective IP addresses. Now notice the IP address here is .1, which is actually the interface I wanted to create on the tier 1 when I did this. So I'm going to close that, but I want you guys to remember that I have those IP addresses configured on the tier 1. So finally, let's go down to segments just to complete the picture. And we'll see I have app-seg here and web-seg here. You'll see here also the connectivity shows that I'm connected to a tier 1-gateway, which is the name, and it's a tier 1 router. And the same thing goes for web-seg, and I can see the associated subnet that I created for that segment. So let's go back now. Let's look at our routing. I want to show you guys, I talked about how the tier 0 ran BGP between itself and the physical network. So let's take a look at it. So if we expand our router and we go down to BGP, you'll see here I specified a BGP autonomous system, or AS. I turned BGP on, and then I added some BGP neighbors. So if I click the neighbors, you'll see here I get a list of 2 neighbors that I configured for this tier 0. Now one of the neighbors is actually showing down because the actual router is powered off right now, but the other neighbor is completely up and everything's fine. So I'm actually able to get in and out of my NSX environment just fine regardless. So let's close that out. And I'd like to also show you guys the interfaces. So you do also configure the interfaces for the router. It's just like a real router. As I said before, there's nothing to this that's kind of a magic box. You actually go in and you're very specific and prescriptive about what you're configuring for NSX. So if I click the interfaces, these IP addresses that show up here and the names and the associated segments that they're tied to, these are all my outbound facing connectivity. This is from my tier 0 out to the rest of the world, to the physical world, not to the NSX side. So I went in and manually created these and placed them on the appropriate VLANs. In my case, I'm using VLAN 21 and 22. So, and don't get hung up on this too much. I do plan to do a deep dive where we'll go through kind of building all of this live, but I wanted to kind of show you guys some of this. So we kind of went through that we have a tier 0, we have a tier 1, and we have segments. So you guys understand that those are there, and you kind of see how they're configured a little bit. Maybe we didn't do it live, but we will, don't worry. So now what I want to show you guys is actually how it's being realized. So you saw that I had those VMs. I had app01 and web01, these VMs right here. I have these on the proper segments, right? if you recall, they're all on the same host, 254.11. Now, this is something that I find really cool. So we talked about before how there's a distributed router component on every host. But let me actually show you guys what that looks like. So I'm going to open up PuTTY here, and I actually just ran this command right before I started the video. I was going to do it live, and I totally forgot I ran it. So here's the output. But I logged into this host. This is 254.11. So this is this host right here. And once I got in the host, you'll see, once I got my SSH connection, I issued a command called NSX-CLI. And that's actually really cool. So if I type in question mark, you'll see that I get these results that are not typical ESX CLI responses. This is not ESX specific command. These are actually NSX CLI. And if I type exit, I would actually exit out of this mode, but I don't want to. What is cool about this is that NSX CLI, if I type get, I can do a whole lot of stuff. I can find out what's connected to what. I can look at a routing table. I really get a lot of detail. Now, in our case, I said I wanted to prove to you that the tier 1 was on this device, specifically the distributed router. So let's take a look. To do that, we're going to use get logical-routers, and this is going to give us the output of basically what routers exist on this host specifically on 254.11. So if I type that in, you'll see what comes back is this UUID. And this is just an identifier. It's nothing more. It's not something that you have to remember or anything like that. This is just an identifier for the logical router. Now, let's say I do get logical router, and I'll do a question mark. You'll see here it asks for a UUID, and in that case, it's asking for this. So let me paste that, and then do another question mark. You'll see my options. I have forwarding, IGMP, interface, interfaces, neighbor. Now, the two that I really care about are forwarding, which is my routing table, and interfaces, which interfaces I've configured on this. Now, let me start with interfaces. So you remember I had configured the 10.200.0.1 for my segment and 201.0.1 for my other segment. Now, let's actually see if those interfaces exist on this host. So if I type interfaces and I hit enter, you'll see right off the bat, I have this segment right here, this 10.201.0.1. I have this interface, which is for my app-seg logical segment. So that is programmed on this host specifically. Now, if I scroll up here, you'll see that I also have my other interface as well, which is right here. So these interfaces exist. So the default gateway for web-seg and app-seg on this host is local to this host. Now, what does that mean? That means, let's say we do our same command we did before, except let's change it to forwarding. And let me make the screen a little bit more readable. There we go. Okay. So if we look at this, the way to interpret this, there we go, that's better. So the way to interpret this is basically the routing table. Once the traffic leaves a VM on this host, it's basically taken by NSX, and NSX says, let me look at that traffic and find out where it's going. In this case, it will follow these routes. You'll see right off the bat I have 10.200.0.0/24 and 10.201.0.0/24. Look at the gateway though. The gateway is myself, and that's because those are directly connected to me. And that's because I have both of those segments directly on this host. So the beauty of this is if I'm going from, say, my web segment, which is on this IP range, on this host, and I want to talk to this other segment, which is on a completely different network, I can actually do all of that routing through this distributed router within that host without ever leaving the host, without ever going to a physical network, which is really cool if you think about it. And it's really efficient. Now, what if it's not directly connected though? What if it's going somewhere else, right? We have our default route. Most of you are very familiar with what a default route is. So I have a default route here, and it shows the gateway as 169.254.0.2. That is the SR component that lives on the edge node. So again, we're going to spend more time later talking about the edge, but that route is directly pointing to the edge. So the way traffic will go is it will hit this DR, it will be routed to the SR, which lives on that edge node over here, and then traffic will be routed from that routing table to the appropriate location. And there's a whole nother routing table that lives on the edge as well. So a lot of people think of NSX as kind of this black box, but actually I have a ton of visibility here. I can see what's going on under the hood, which for me personally, I'm a big fan of. I like the GUI, but I like to actually see stuff working, and maybe I'm just old school. I don't know. So I wasn't going to show you guys the edge piece, but I do kind of want to show you the routing there. So I think what I'm going to do is actually hop over to the edge real quick, and we'll call an audible here. So let's go to PuTTY, and I'm going to go to edge 01. And I'm going to type my credentials in, if I can remember them. There we go. So this is where it gets interesting. So now I'm logged into the Edge VM itself. So keep in mind, I can't stress this enough. The Edge is a container which holds virtual routers inside of it, and it could be multiple virtual routers. So don't think of the Edge VM as it's just one router. That's just not how it works. So we have kind of the same syntax that we have on our host with the NSX CLI. Let me expand this out a bit so you can read it. So here, let me try just right off the bat. We know our get logical-routers command. Let's type that, see what happens. Now, you see here I have a few other options, and it gets interesting here because you see I have this DR component, which if you recall, I said the distributed router lives on all of the hosts. In this case, the Edge VM is treated like another host. So it gets a distributed router component, and it gets one not only for the T1, but it also gets one for the T0. You also recall I talked about the SR component, which is the on-off ramp. And those are right here. I have the SR for Mike's Tier 0, and I have the SR for Mike's Tier 1-gateway. So the important thing to take away from this screen is really you want to look at this VRF column. So I have these VRFs, and these VRFs are actually segmenting my traffic. Now, let's take a look at the actual routing. So once traffic gets routed to the SR for the Tier 0, how does it get out? What does it see to the rest of the world? So to do that, we're going to type VRF, and we're going to specify VRF1 because that's the VRF that's listed right here for Mike's Tier 0 for the SR component. So we'll type in VRF1 and hit enter. You'll see right off the bat it drops us into this Tier 0_SR. Now if I type get, things change a little bit. You'll see that the commands seemed a little different than they were before. In this case, I will type get forwarding first. You'll see here again, I have a bunch of routes. Now, I probably should have issued another command, which I'll show you. I'll show you guys some of the BGP stuff, but this is good too because you can actually see these segments. These are actually those IPs I showed you earlier, the interfaces I created on the Tier 0. That's these IPs right here. So it's showing me locally connected routes on the physical network. It's showing me routes internal to the NSX environment. So those app-seg and web-seg, those routes are right here. And I'm getting even things like the routes between the routers are showing up here, which is that internally generated range that I spoke of earlier. So let's take a look at BGP. And you don't have to be a BGP expert to understand this. I just want to show you guys. So if I do get BGP neighbor summary, and hit enter, you'll see that I have two BGP neighbors. So I'm sharing routes to and from 22-10 and 21-10, which are my CSR routers in my environment. And you'll also see here that, remember, one of those is actually down. We saw that in the GUI, so that's why we're seeing here it shows the state is active, which means it's down essentially. And then we also see we're not receiving any prefixes or sending any prefixes out or routes out. We do see on the other neighbor, though, we are sending and receiving 4 routes. So let's take a look at those. So for that, I'll type in get route and hit enter. Now you'll see here that we have this really nice kind of this guide to understanding what all of these. If you'll see here, we have this nice kind of guide that explains what all of these little abbreviations mean. But honestly, they're pretty self-explanatory, and I think once you do it a few times, you get them pretty quickly. So in this case, T0C, so C means connected. So that means these routes are directly connected to the Tier 0. T1C is the same thing, but for the Tier 1. And you'll see that we have those routes for those interfaces that we created for the segments. B, of course, means BGP, so we can actually see that we're learning this route from the outside network into the NSX world. You'll also see that we're generating a default route into NSX, which is typically what I see, but it's not an absolute requirement. Well, that's all I have for you guys today. Oh, horrible, so horrible. Well, that's all I have for you guys today. I hope this video was helpful. I will say there's gonna... So that's all for today. Again, appreciate the support. Thank you, everyone. Take care. Definitely subscribe, like if this video was helpful, and comment. That's the most important part. Tell me what you found useful. Tell me what you didn't find useful. Tell me what you guys want to see.